Welcome to Red Tech channel, a new way to learn. Basically, we're going to study X-ray tube in parts. We study today the part 1. In this section, we just a quick review about the X-ray tube. Actually, what is in the X-ray tube. So let's begin. Tube design. Basically, in tube design, the X-ray tube convert electric power from the generator into X-ray photons. The electricity come from the generator and the conversion of electric power into X-ray photon basically. And X-ray tube containing basically negatively charged cathode containing filament and serve as a electron cloud. And the anode, one is cathode and another is anode. Cathode having negatively charged, anode having positively charged, and at cathode there is a electric source, you can say that. And anode is basically a target where X-ray are heated or where X-ray are basically produced. Anode may be stationary or you can say rotating, which working in vacuum, and both the anode and cathode are enclosed in a evacuated envelope, basically in vacuum with no air present, which prevent electron collide with gas molecule and loss of kinetic energy. Basically, if there is some gas or you can say air present, so when electric current energetic electron accelerating towards anode, they might lose their kinetic energy also. And in the envelope containing tube housing, which basically protect the tube and provide the shielding and prevent leakage of radiation. Basically radiation leakage, to prevent leakage of radiation, we provide tube housing which contain oil bath with which help to cool the tube. And basically primary X-ray exit through a window, basically a thin glass of window present in the tube house. And basically we should remember a point also, in mammography window are made up of beryllium which absorb low energy X-rays. Basically we having low energy X-rays which can make noise in our image, so to absorb those rays in mammography we apply or we can say we add the window which is made up of beryllium. We should remember this about. So this is all about a quick review of X-ray tube. So today in basic physics we are going to study X-ray tube part 2. Please watch the previous video before watching this. The link is given in the description. So let's begin. Filament. Basically what is filament? Filament is our negative terminal of X-ray tube. Basically you can say that negative end of X-ray tube, which is made up of tungsten. And also the tungsten also called the filament of the X-ray tube. We mostly use the term filament, so we should remember that tungsten is also named as filament, and which is the basically source of electron from where the energetic electron or you can say electron accelerated towards the anode and produce X-rays. This is basically about the filament, which how it is work and what the filament is made up of. Basically tungsten is the filament hour. And filament basically usually made up of coiled tungsten wire, means having coiling of tungsten wiring. But in modern X-ray tube we using two filament, having many other reason to allow choices of two focal spot sizes. This makes the life of X-ray tube longer than unusual. And voltage across, if we apply voltage across in the X-ray tube around 10 voltage, and the current through the cathode filament are 4 ampere, then we produce power dissipation about 40 watt 40 around. Then question may arise in your mind that why we using the tungsten in the X-ray tube. So basically the answer is because of having high resistive temperature providing the filament to heat up in the higher temperature, which is the highest limit is 2200 degree Celsius, which is very huge, huge temperature basically, and which is the resulting thermionic emission of electron, basically releasing of electron from their surface, or you can say from their part. And we using the focusing cups around the supplement and provide to direct towards electron, because if we not provide any focusing, that electron may divert, so we provide focusing cup to give direction to the our electron. Tube current. Tube current basically refers to that flow of electrons from the filament to the targeted embedded in the anode. Means the flow of electron means energetic electrons flowing from the filament to the target, or you can say anode. Well, electrons emitted from a heated filament. When filament got heated, the electron emission start from negative to positive direction and form a negative cloud around the filament, which is basically called space charge, which prevent further emission of electron. Otherwise, emission of electrons continuously, and our tungsten may harm, or you can say may useless very soon. And at very low voltage, it is impossible to pull away all the electrons from the filament, so there is some residual space charge remain in the filament, or you can say in the outer of the filament. So that's basically space charge limit. So I hope this is the tube current, basically energetic electrons flowing from the filament to the anode and targeted and hit the anode and form the X-rays. But the to prevent for further emission of electrons, there is a negative cloud around the filament, that is basically called space charge. So now move to at saturation voltage, our electrons are immediately pulled away from the filament. When saturated voltage, electrons go away from the filament and X-ray tube current is maximized. Basically tube current is increasing with increasing of filament heating. That's basically common sense. If we heated the filament in a large amount, the electrons are also emitted in large amount and the tube current also produced in a larger way. And tube current ranges from 1 milliampere to 1200 milliampere. That's basically limit, or you can say range of the tube current ranges. We have to remember the point is, if we heat the, or you can say if we power up the filament, or you can say heat up the filament, the emission of electrons are in a same way, or you can say tube current is directly proportional to the heating of the filament. That's basically we have to understand about that. So I hope you clear out all the points. Focal spot, basically how much the area of the target struck by the electron is determined by the two. The one is filament size, what is the filament size, and the focusing cup, what type of focusing cup is used. So two terms determines the area of the target struck by the electron. And the another is term is focal spot. The spot is size of the source of X-rays, means the X-rays are generating from the machine, and the size of the rays as viewed by the patient. This is basically focal spot, and it is basically based on line focus principle, which permit larger heat loading capacity, you can say, when while using small focal spot, or you can say while minimizing the size of focal spot, we can acquire, or we can adapt the large heat loading capacity. This is basically line focus principle. When the width of X-rays are coming, it allow it goes in a narrow line. This is basically focal spot, and mainly in this the anode angle play a vital role in determining the focal spot size, because in this anode angle put it from 7 degree to 20 degree, or you can say tilted at 7 degree to 20 degree. So to make or to ensure that the small focal spot size, this is determined by the basically anode angle, which play a vital role in this. And you have to remember the line focus principle. It allows the large heat loading while minimizing the size of focal spot. Size of focal spot, basically how much the size of source of x-rays, the amount of x-rays goes in the size, small or the large size, this is basically focal spot. And the term I used earlier, that anode angle, basically the angle between the target surface and the central beam. What the target surface and the between angle between the target surface and the central beam, this is basically the anode angle. And you have to remember that focal spot needed small to produce sharp images. While using the small focal spot, you can produce the sharp images, but while in using the large focal spot, it has high tolerating heat loading capacity, you can say larger one to tolerate high heat loading. But we have to maintain the balance in the image. We want the image sharp and the high heat loading also, so we make the equilibrium in both the cases. So we maintain the image is sharp image and the high heat loading. So focal spot size is mainly manufactured by around 0.1 mm 2. So here you can see the diagram of the focal spot, and the whole scenario suggests to you that line focus principle. Here the comes out the size of x-rays are wide, but below you can say when x-ray are produced, the narrow line coming out from the anode. So the anode angle play a vital role in making the narrowing of the X-ray tube, or you can say small focal spot. This is basically about the focal spot, which is very essential to understand for every radiographer. Anode basically the target side of the X-ray tube, or you can say target. Anode is the electro striking the target, producing basically to the heat and the X-rays. Anode you can say also target also, both are same. And when electron are striking the target, which produces heat and the X-rays. Basically now the target is embedded in a anode material. Basically target is enclosed, or you can say in an anode material, by temporarily store the heat energy deposit in the target. Basically in the target embedded the anode material, which basically store the temporarily heat energy in the target. And in the X-ray tube, basically we uses the two types of anode. The one is stationary anode, another is rotating anode. So now look to stationary anode. Stationary anode usually consists of, mainly we use tungsten target, as we know about the tungsten material embedded in a copper block. Enclosed, you can say that the tungsten is placed in a copper block because copper is a good heat conductor and heat dissipation is limited. Means having good conductor can conduct heat, and dissipation means spread out of the heat. So heat dissipation is limited, so we use the copper block and placed tungsten in it. And stationary anode basically used in portable X-ray units, or you can say portable X-ray machines. Now look to rotating anode. Rotating anode greatly increase the effective area during the exposure. So their heat capacity is much better than, or you can say better than, stationary. To maintain the vacuum inside the X-ray tube, rotating anode employ an electric induction motor. So in the rotating anode, to maintain the vacuum in the inside the X-ray tube, so we place the, or you can say, induction motor, and the rotor turns in response, changing electric current into static electric windings. So the rotor turns the stator electric windings, which convert the electric current, so changing the electric current. So this is all about the anode. We must remember the stationary or the rotating anode. I hope you clear out all the points. So this is the X-ray tube with diagram. A quick review about the X-ray tube. So let's see. Here you can see in the diagram the anode rotator. In the anode, basically we uses the two types of anode. One is stationary and another is rotator, or you can say rotationary anode. Basically the lifespan of the anode of having rotator, or you can say rotating anode, having more than the stationary, because of the area which is hit by the electron is increased by, or you can say expanded by, the rotating anode as compared to stationary. And tungsten target is used in the X-ray tube, which is enclosed, or you can say enclosed in the copper block, which is basically our good heat dissipation also. Now look to filament. Here you can see the filament, and the to the anode side the electrons are comes out from the cathode direction and hit to the anode point, or you can say anode direction. This is basically the direction of the electrons moving in the X-ray tube. You basically remember this point also. Filament basically high melting point, and this basically now move to tube current. Tube current basically the electron flowing in the X-ray tube, that is basically our tube current. The electrons come from the filament and the hit to the anode, which generate the X-rays. And you have to remember, the point is the only 1% of the energy which is comes out after hitting the anode, when hit the electron to the anode, and the energy released from that, the 90% of that energy wasted in the heat form, and the 1%, only 1% of our total energy will produce in the X-ray, or you can say 1% of that energy produces X-rays. So this is basically the whole process, how the electrons having role in the X-ray production. And both the anode and cathode, or you can say the X-ray tube having no air, or you can say the X-ray tube having vacuum, because of if the present of air and some molecules, our electron, energetic electron you can say, can lose their kinetic energy before hitting the anode. This is basically the reason why we kept the X-ray tube in a vacuum, and we use the tube housing and the window also having low atomic number. So I hope you clear out all the points. So that's all for this video. Do subscribe if you like, and thanks for watching.